We all know that cars have to meet emissions and fuel economy standards. Well, this is where they get tested for it, at the National Vehicle and Fuel Emissions Laboratory in Ann Arbor, Michigan. And the reason I'm standing here is that my guest on today's show is Chris Grundler, the Deputy Director for Vehicle Transportation and Air Quality at the EPA. You know, they don't just test vehicles here, they're actually developing some fascinating technology of their own. And we'll be getting into all that right after this.
This is Autoline. Here now is John McElroy.
Chris, thanks so much for taking the time to talk with me all about the EPA Lab here. It's great having you on Autoline again.
It's great to be here.
So before we get into all the discussion that we want to do today, tell me about the room I'm in. Everywhere I look, there's fuel pumps. What's this all about?
Well, I'm very happy to say that this is our new fuel distribution facility. This is essentially our gas station here at the lab, although it has more than just gasoline as a fuel. And we've been here since 1970, and we've had the same fuel distribution facility until now. And we've finally been able to get the resources to modernize it. It was becoming a safety concern. Plus, with all the new types of fuels in the market, you know, we need to have all those fuels here because we test our vehicles using these different fuels. So now we have a modern, safe fuel distribution facility here, and we're very pleased.
So you've got gasoline and E85 and diesel, and I imagine biofuel and all kinds of things here.
Exactly, in all different types of blends. So we can blend any different type of mixture that we need with this modern equipment, and we can do it safely and precisely. Precise measurements matter a lot in this business.
Every automaker in the world that wants to sell vehicles in the United States has got to bring their vehicle to this lab, do they not?
That's correct. So this is a national laboratory. It's a very important public asset, in my opinion, for two reasons. One, our job is to make sure that the public who pays our salaries and pays for this facility, thankfully, gets the benefit from the national standards that we develop here. So we predict lots of benefits by implementing these standards, but they're projections. So what we do here is make sure that cars that are sold, as well as cars that are being used, actually meet those standards in use, where people are breathing and they get those public benefits that we're projecting. But the second benefit, which I think is more of an economic benefit, is our job here is to make sure that there's fair competition, that there's fair play, that there's a level economic playing field, if you will, so that people know that I'm following the rules, I'm making the investments, my cars are clean, I want to make sure my competitor is doing the same thing. And so we're that body that makes sure that that happens. And especially now, as you know, John, the business is transforming very rapidly. We're getting lots of new types of technologies into the marketplace. We have many new entrants from India and China. And it's important that there's fair competition and everyone's doing it the right way. And it's our job to make sure that happens.
Do you do more than vehicles? What about lawnmowers or wave runners or any sort of thing like that?
We do. So our name is the National Vehicle and Fuel Emissions Laboratory. We're part of an organization called Transportation and Air Quality. And so what that means is we worry about everything that moves that makes air pollution. So that means from both a weed whacker to an ocean-going vessel, we establish emission standards for, because they all contribute to the air we breathe. And it's a significant contribution. Even something as you wouldn't think of it as a weed whacker. Why worry about weed whackers? And the reason is there are lots of them. They make a lot of volatile organics, especially in the summertime when ozone and smog are being produced. And so when you have a combination of a large number of things that burn fuel at that time of year that generally are low technology, it's our job to worry about them.
You mentioned ocean liners. We're a long way from the ocean here in Ann Arbor, Michigan. How do you test that?
Well, we don't test them here, obviously. And we don't actually have specific U.S. regulations. We work through a body called the International Maritime Organization, which is the international UN body that regulates maritime affairs. And through that body, we very recently, in fact, had a huge success in establishing around the coastline of North America a zone out to 230 nautical miles where ocean liners have to switch to much cleaner fuel. And then it's the Coast Guard's job to make sure that that happens, or they don't get to come into our waters or into our ports. We've also established engine standards that new ships have to meet, and it will be the Coast Guard's job to execute those standards. And you wouldn't think that that would make a huge difference, but that's actually, that move alone, the clean fuel and the cleaner engines, is going to save thousands of people's lives starting in 2030 when those are fully implemented. And the reason is because those emissions drift inland. We measured public health benefits as far inland as the state of Michigan, for your viewers who probably care about that. So it's not just along the coasts. And the fuel that those ocean liners use right now is filthy. It's called bunker fuel. It's these residual fuels. You actually have to, the ships have to heat them up in order to burn them in their engines.
Sounds pretty nasty. Let's get back to vehicles.
Okay.
You mentioned Indian and Chinese companies. They've been bringing vehicles here for you to test?
We haven't tested a vehicle yet, but they have been in contact with us based on their future plans. So we've been talking to Mahindra, to Tata, to BYD and other Chinese makers, and teaching them what the rules are and what the processes are for them to do business in the United States. So they are learning, we are teaching them, but they've not given us a vehicle yet for certification.
You mentioned earlier, of course, that we're seeing a lot of vehicle technology change. I imagine hybrids, but more particularly electric vehicles, are going to force you to change what you do here at the lab because you're testing batteries and not engines.
That's correct. As you know better than most, the industry is going through a huge transformation, and we're seeing, and I've never seen it such a rapid transformation, which is, as a Michigan native, very heartening to me. I mean, I think this industry is going to lead us out of recession, and is, and always has been. But what's interesting to me, particularly when you go to the auto shows, is how fast everything is moving. And I think it's a sign of how quickly the business is changing by virtue of how quickly they can bring new products to market. And it's not just the innovation for customers, but these new products, I think, are going to produce all kinds of benefits to society as a whole. And so I think it's a great story. What it means for me and for EPA is that we have to adapt as well. And so we need to be able to test these products. We need to be able to understand the technology very, very well, because the last thing we want to be is a barrier or a hindrance for companies to bring new products to market fast. And so we are, in fact, adapting. We are putting in battery testing capability here. I mentioned all the new different fuel capability we have here. Right now, we only have one four-wheel drive dynamometer. To test a hybrid properly, you need a four-wheel drive dynamometer. We're expanding that capacity here, so we'll be able to properly test conventional vehicles, which we think there's still a lot of room for improvement there in advanced gasoline engines, plug-in hybrids, battery electric vehicles, and the whole range of vehicles. We'll be ready.
You said something very interesting there, that to test hybrid vehicles properly, you need a four-wheel drive dynamometer. That is a dynamometer that can test vehicles with four-wheel drive.
That's
Why
right.
do you need that for hybrids?
To capture properly the the efficiency gain from how the vehicle is braking. So you need to take measurements on both axles to be able to capture the efficiency gains from this hybrid technology. Now you can do it on a two-wheel drive by disconnecting an axle, but it's not the best way to do it.
In other words, let's say a hybrid's front-wheel drive, and you've got a dynamometer where the front wheels are turning on this dyno. But to capture when it goes into a braking mode, you really have to measure the forces at the rear wheels as well.
And also, a lot of these vehicles are all-wheel drive capable, so they're sending power to both sets of wheels differently. So that's why we want to capture that.
How about hydrogen? There's a lot of talk amongst automakers of having fuel cell cars in the middle of this decade. Are you looking at them as well?
Yes, we are, and we'll be able to test them as well. We do have hydrogen testing capability here. We don't expect to see them as soon as some of these other vehicles, but we'll be ready for those if the market is demanding them.
Chris, this is an enormous facility. I had no idea. I've driven by this a lot of times, but coming in here, I realized just how big it is. It seems to me that you're doing more than just hooking something up to the tailpipe and putting it on a dynamometer here.
Yeah, We've been here since 1970, as I mentioned, and we've always been an economic magnet. So we started here in 1970. The automakers had to build their emission laboratories, and when foreign companies became selling much more of their product in this country, they built their own satellite emissions labs around us, and then they started adding to those emissions labs other developmental capabilities. So we've really been an economic engine for Southeast Michigan, and we did a rough, very conservative calculation that we've created about 15,000 jobs just by the fact that we're here, and that's not counting all the investment in advanced technology that's happening now that our standards are inspiring. But it is a one-of-a-kind place. There's no other facility like it in the country. As a matter of fact, we've got about 160,000 square feet here, and we test everything from small engines, which I'd be delighted to show you if we go do a tour, all the way up to medium-duty vehicles. We're a little bit limited on that, and we hope to add capacity to test the largest vehicles because they're a big part of the air pollution story as well. But we don't just do that here. We also have an advanced technology program. Over time, our philosophy is to be a smart regulator. You really need to understand not only technology but also the business. So we spend a lot of our time making sure we understand the business of selling cars. We understand the development process. We have a deep understanding of technology and what it can do. And so out of that, over time, our engineers develop their own insights into technology and develop novel ideas. And Congress actually encourages national lab engineers to develop that and create that intellectual property and then share it and transfer it with a preference to U.S. manufacturers. It's called the Federal Technology Transfer Act. And so I'm very proud of the fact that this lab has been awarded over 60 patents in the automotive engineering field. And we have an active program to license that technology and share that technology with our partners in the industry to move that technology to the market where it'll do good.
In fact, we've got to talk about one of those because you've developed a hydraulic hybrid here that most recently the Chrysler Group has shown an interest in, possibly to make a hydraulic hybrid minivan. Tell us a little bit about that program.
Well, it's a different kind of hybrid, which uses hydraulic power as a secondary source of power instead of electric power. So instead of a battery, we store energy in a hydraulic accumulator through pressurized fluid. And instead of an electric motor driving the wheels, we have a hydraulic pump motor. And so it works essentially the same way, except our hydraulic hybrid is a series hybrid. So the engine is never connected mechanically to the wheels. The job of the engine is simply to pressurize the hydraulic fluid, and then the hydraulic motor drives the wheel. The advantage of that is you can operate the engine in its sweet spot. So you get a lot of efficiency gain by running the engine where it likes to be run. Secondly, a series hydraulic hybrid, or a series hybrid in general, spends a lot of time with the engine off. So you gain savings there as well. And the third advantage is hydraulics can capture braking energy much faster than a battery can. So that's why we think this technology, and it's a niche technology, we were working on it because no one else was, has a great deal of potential. And finally, they're cheap. Hydraulics have been around for a long time. They're invented in America. We make a lot of pumps. We make a lot of tanks. It doesn't need any further breakthroughs in battery technology, for example. So it's just a question of getting the volume up to get the cost down, because essentially it's steel. These are battery pumps, and actually, the tanks now are composite material because to save weight. But it's a really interesting concept. It's on the road now in delivery trucks and garbage trucks. And the Chrysler project is all about seeing what the challenges are to adapt it to a passenger vehicle. Can it be packaged? We know it works. But can it be packaged appropriately? And can it meet the other customer demands in terms of drivability and NVH characteristics? And that's what Chrysler is bringing to the party. They know a lot about NVHs. They've been out taking lots of measurements on our hydraulic trucks, and they're optimistic that they can solve this problem. And the savings are huge.
That's the one thing I always heard about hydraulic hybrids, is that they're noisy, which in a garbage truck or delivery van may not be that important, but in a passenger vehicle, very much so.
Yeah, that's true. And garbage trucks are very noisy, so you're not going to hear the hydraulics. But actually, customers are going to find that their garbage truck is a lot quieter, because going from stop to stop, they're going to be operating on hydraulic power, which is a lot less noisy than the diesel engines in it right now. Another interesting aspect that makes it such an interesting and attractive business proposition to the people that make refuse trucks is they go through 4 sets of brakes in a year. And with this hydraulic technology, they're going to save all kinds of money by not having to replace brakes so frequently, because they've got this hydraulic system that is slowing and braking the vehicle.
So they'll save money on the maintenance and repair of the truck.
Big savings on the maintenance in addition to the fuel, correct.
Now, when the EPA first announced this hydraulic hybrid, I want to say it goes back something like 7 or 8 years ago, and Ford was very interested, and the Eaton Corporation was interested. Eaton, I guess, has stuck with it, but Ford dropped out. So why is it taking so long to get something like this to the market or to higher volume?
Yeah, we had a very big program with Ford, and they were very serious about it. And they made the decision that they couldn't afford to pursue that any longer. If you remember, this was in the 2004-2005 time frame. Ford was in a pretty difficult situation, and they made the choice to focus on their Escape Hybrid, which was also in development at the same time. The technology has progressed quite a bit since then. It's gotten lighter, it's gotten more efficient, and we always thought that the first application should be in these big commercial vehicles. But it's a conservative business, particularly with respect to a series hybrid, which has the biggest savings. That takes a certain leap of faith to tell your customer that the engine's not connected to the wheels and it's going to be okay. So Eaton, for example, has been selling a parallel hybrid system, which is kind of their first entry, and it's not as efficient because it's a parallel system, but so the mechanical system is still, the engine is still attached to the wheels. We have another partner in Parker Hannifin, which is a major hydraulic supplier, and Autocar with the refuse truck, and that's a full series hybrid. And they're running on the streets right now in Florida, and there are more to come, and they're selling that product now.
That's terrific. That's great to hear. What else is EPA working on? I know some years ago you were talking about controlling diesel emissions right in the combustion chamber rather than adding on all kinds of emissions equipment. Where's that, and what else is EPA working on?
Yeah, so we have a clean combustion technology here that we invented, that we're sharing with a number of partners, including Ford and Navistar. And that is kind of a high boost, low temperature combustion approach that reduces in-cylinder emissions. It still needs some after treatment for particles, but not for NOx. And we're also working on a HCCI engine, which I'd love to show you, which is going into a shuttle bus, a hydraulic hybrid shuttle bus that we're building for the South Coast in California. And that's a very interesting technology because it runs on gasoline, but has a diesel's level of efficiency, but a gasoline's level of emissions. And it's perfect for a series hydraulic because you can control it again in its sweet spot. And so we're very excited about that. And we're also excited about, now that we're almost complete with the technology transfer process for hydraulics in large trucks, we have this novel idea of combining batteries with hydraulics and get the best of both worlds. So we've got a little project right now with the University of Michigan to try to measure the benefits of this. But here's the idea, and I really think it's a winner. You just put a small hydraulic system on there to launch the vehicle, because you use a lot of battery energy, launching the vehicle and getting up to speed. So what if you use hydraulics to do that? And what if you use hydraulics to capture your braking energy, because it's much more efficient than a battery? What would that do to either lower the costs of battery vehicles or extend the range? And we think the modeling we've done there looks very, very promising.
But what about cost? Because unquestionably these kinds of technologies you've mentioned can improve fuel economy and reduce emissions. But at what cost? Can you get a payback on it as a consumer or as a fleet operator?
Yeah, and the answer is unquestionably yes. We've got a lot of experience here costing technology, and we've got a lot of experience here measuring fuel economy. And so we have measured the benefits of hydraulic hybrid technology in UPS vehicles delivering Christmas presents in southeast Michigan each of the last few years. And the numbers look really good. A 50% reduction in fuel consumption. And so obviously it depends on how much fuel you buy every year and how long you keep your vehicle. But our estimates are, at high volume, maybe 50, 100,000 units a year, we think the payback's going to be in most applications less than 3 years, and in some cases less than 2 years. It's all going to be dependent on how you use, what your fleet is doing and how you use the equipment. But again, think about it. We're not talking about needing any kind of engineering breakthroughs to make this stuff work. This is all application engineering we're talking about now. So applying it to the vehicle, applying it to how you use that vehicle. That's what's left to do here to make this a big deal.
Are you able to get the kind of talent that you need here at the lab? I imagine that, especially as you get into electric vehicles and even hybrids for that matter, it takes an engineering skill set that may not have existed out in the industry right now. Can you get the kind of people that you need, or do you have to grow it and nurture that?
We do both. We've got a highly trained and educated workforce here. Last I checked, over 40% of our employees have advanced degrees in engineering. We recruit nationally from the top engineering schools. Of course, we don't have to go very far. We just go across the street to the University of Michigan, my alma mater. But we also do a lot of hiring from industry itself. And again, it gets back to our philosophy about establishing common sense standards. So we have people here who, in a past job, used to run a small oil refinery. So he knew what it takes to run an oil refinery and how to make the fuel cleaner. The guy that is a key part of our technology program used to run the advanced engine program for John Deere. We've hired people from Cummins. Lately, we've hired a lot of mid-career people from General Motors, Chrysler, and Ford. And this is very, very important because it gives us, again, that perspective of what it takes to build a vehicle to meet customer needs, as well as how to make them perform to provide fuel savings. So I'm very happy with our talent. To be honest, I'm a little bit worried about the billboards around Detroit saying, by General Motors and others saying, we're hiring advanced engineers, come talk to us, because I can't offer them a car plan. But our retention numbers here are very, very good because we think we know we've got a very important mission and people like to work here on it.
Well, I love hearing that you're having problems competing against the car companies hiring people, because we love hearing about people getting their jobs back here. But Chris Grundler, thanks so much for taking the time to talk with me. It's
Delighted.
been great, very interesting.
Thank you.
I really have to thank Chris Grundler, and in fact the entire EPA crew here at the National Vehicle and Fuel Emissions Laboratory in Ann Arbor, Michigan. They really threw out the welcome mat for us today. In fact, we were able to shoot a lot more of what goes on at the lab than we could put in today's show. You can find that right now on our website.
This is a control room for our heavy-duty engine certification and compliance site. This is Chris Bond. He's running a test here on the Cummins engine, which he assures me is quite clean. So this is part of what we do here, which is to get engines before they're sold and to measure their emissions and their performance to make sure that they meet our public air standards. So
let's go in there and take a look.
The smell of diesel we hope to put into service in a couple months. And here you can see the different components of the system. This is the hydraulic drive motor that replaces the transmission and provides power to the wheels. Here are the hydraulic accumulators, carbon fiber tanks, a little over 5,000 psi. The engine's out. but this is going to receive a HCCI gasoline engine, which is very, very efficient as a diesel engine, but with the emissions of a clean gasoline.
Dumping all the onus of cleaning up the air on just the car companies.
Exactly. And what's also interesting about these emissions is they tend to, in the lawn and garden segment, they come in the warm summer months where the atmospheric conditions are ripe for forming smog and ozone. So this is a very important area for us to control. What's also interesting about this segment is we're seeing a big change in the marketplace, because we're seeing a huge number of new modeling tools to simulate the best strategy they want to employ. Year 2, they're given a free, high-quality General Motors vehicle to change, and that's when we come in. Year 2 and Year 3 involve testing, and so last year we were out at the Proving Grounds in Arizona testing vehicles for emissions and fuel economy using our portable emission measurement systems. And now, at the end of Year 3, they're going through very rigorous set of testing over the last 2.
But that brings us to the end of this show. For all of us here at Autoline Detroit, thanks for watching. We'll see you next week.